Let's consider two sentences. The 500th digit of pi is 8, and x is an even number. The first is true or false, but we might not know which. However, it does have a definite, although unknown, truth value, and so it's a logical statement. In contrast, the second sentence is true or false depending on the identity of x. So it will be true for some x and false for others. To distinguish between a sentence that has a definite, even if unknown, truth value, and a sentence that is sometimes true and sometimes false, we call the latter an open sentence. Since we'd much rather have definite truth values, we'd like to be able to write open sentences as statements. To do that, we can use a quantifier. Let's consider two possibilities. Our statement might be true for all values of x in some set, or our statement might be true for some of the values of x in the set. Suppose our open sentence, we'll call it p of x, is true for all values of x in the set. We'll write this way, and we'll read this as for all values of x in S, that's this inverted A, p of x. We call this our universal quantifier. On the other hand, suppose our open sentence is true for only some values of x in our set, but is true for at least one. We'll write this way, where this inverted E is going to be read as there is some x in our set for which p of x. And we call this our existential quantifier. For example, let S be the set of odd numbers and consider x in S. Let's write a true statement using the open sentence, x is a prime number. So note that if x is in S, then x is an odd number, and our open sentence will be about that odd number. And so we note 3 is in S, and 3 is a prime number is true. 5 is in S, 5 is a prime number, that's true. 7 is in S, 7 is a prime number, that's true. 9 is in S, 9 is a prime number, and that's true. False. And that means that since x is a prime number is true for some, but not all elements of S, we'll use our existential quantifier. And so we'll write it this way, and we should read this as there is some x in our set of odd numbers, where x is prime, and this is a true statement. Or let x be a prime number greater than 2. Let's write a true statement using the open sentence, x is odd. So note that the open sentence, x is odd, will actually be true for all prime numbers greater than 2. And since this is going to be true for all x in some set, we can use the universal quantifier if x is a prime number greater than 2. And so we'll let S be the set of prime numbers greater than 2. Then for any x in that set, x is odd, and this is a true statement. Now, it's important to remember that in logic, we're more concerned with the structure than the content. So you should probably know what a prime number is. You should probably know what an odd number is. But as long as you understand the distinction between the universal quantifier for all x in a set and the existential quantifier for some x in the set, then the logic will take care of itself. So, for example, let's try to write as a statement, all quasits are glurby. What's a quasit or glurby? It doesn't matter. Even if you did know that a quasit is a matriculated terpsichore and that a glurby is a fromulated yaprak, it wouldn't actually matter. What you want to focus on is the statement, all quasits are glurby. So first note that this statement is a claim that things are glurby. So the open sentence is that something is glurby. And so let Q be the set of quasits and G be the set of glurbies. Then our statement is going to include as an open sentence, X is in the set of glurbies. But this is true for all quasits, and since it's true for all quasits, we use a universal quantifier. And so we'll preface that with, for any x that's a quasit, then x is a glurpy. Or we might write as a statement, some glurbies are rarcar. This is a claim that something is rarcar. So our open sentence is that x is in the set of rarcars. So let G be the set of glurbies and R the set of rarcars. Then our statement is something about x being in the set of rarcars. But this is only true for some glurbies. So we use the existential quantifier. And so our statement becomes, there is something that is a glurby that is in the set of rarcars.